All right, good people. Today is the 15th. Today is the 15th. The agenda is on the sideboard. We're going to write in our planner. I'm going to go over the warm up. Okay. Today, I'm going to model how to read graphs. I'm going to talk about that, how to read graphs. And then there is a graphing matching that we're going to be doing. We're going to do some guided practice. And then we have a graph cut paste. It's actually the cut and paste one. The matching is tomorrow. Cut paste is today. Cut paste activity, okay? On reading graphs. Tonight for homework, you need to complete the homework. Make sure you watch in the packet. Make sure you watch the help video. All right. Make sure that you also write in your planner. Check off if you watched the video yesterday. Check off if you completed the homework yesterday. And write the homework down for today. I'm going to pause for the calls. Please do not forget that I'm going to be checking your planner and giving you extra points for having everything written like it's supposed to be. Do not forget, after you write this down, write tutoring for Thursday. Remember, your tutoring session is after school at 2:30. You have language arts first, and then you'll have me for math second. Okay. All right. Your ride needs to be here by at least 4 o'clock. All right. Let's warm up. So with the warm up, you're finding the M or the rate, the slope. You're using the formula y2 minus y1 over x2 minus x1. I'm going to use the first 2 points, 0 and -4, x1, y1, and 1 and -2, x2, y2. We're going to substitute. What are we going to put on the top? What goes on the top? What minus what? Yes, Riley? -2 minus a -4. What's going to go on the bottom? 1 minus 0. Okay. What do we get on the top? This is minus a negative, which is plus a positive. So what do we get on the top? 2. And what do we get on the bottom? 1. So this is going to be, M is going to equal to 2. That's our slope. All right. How do we figure out what the starting amount is? Yes, Paige? It's where, it's not always going to be first. It's wherever x is equal to 0. So wherever x is equal to 0, that y value is your b. Your starting amount is -4. It's not always going to be the first number, okay? Okay, so how do you write your equation in slope-intercept form? Y equals mx plus b.
Y equals 2x.
Very good. You're going to pause for the calls. Make sure you clear your tabletop. Put all of your materials under your desk. Put your calculator there as well so that the tabletop is clear. Okay, so that when we come in, we'll be able to eat lunch in a clear space. Do not forget, if there's any food or anything on the floor, then we'll have assigned seating where we sit and eat lunch. Okay, we're way too big to keep missing our mouths. We need to put the food in our mouth or in the garbage, but not on the floor. Okay? Here we go, y'all. Okay, so make sure that your name is, we're going to put this one in. Am I going to turn this in? We're going to put this one in our notebook. Please take out your interactive notebook. We're reading graphs, so we're going to do some short notes. Page 9 on reading graphs. Real simple. Some of it is common knowledge. You're going to get it right away. Shh. Okay. What do you want me to do about it? Nothing. Hey, baby. All right, here we go. We're not doing test today.
No, I'm not going to be here Thursday. So I asked you if I could do it early, and you said yes.
Oh, I didn't know it was this early. We're not even finished. You're going to have to do it when you return. This is the last skill, and you're not here to do the last skill. That's why I was like, I'll make it all period, because it's the last concept that I need to go over.
Okay. Let me get my stuff up.
All right, here we go. Boy, bye, that is not the reason. All right, Q3. This is page 9. We're reading graphs. When you are reading graphs, the first thing you need to do is read the title. You can make a lot of inferences by reading that title and understanding what that graph is actually trying to graph. And the graphs that we're actually reading, I'll go ahead and put up here. It's time. It's time versus motion. That's the type of graphs we're going to be reading. After you read the title, then you need to make sure that you read the X and the Y axis. You need to read the X axis and the Y axis. This is the X axis. This is your Y axis. I'm going to pause for the calls. Terrence, write this down, baby. God, oh shit. All right, here we go. This is time. Time you graph along the X axis. This is where the motion is going to go. Motion you graph along the Y. Part of reading the graph is look to see what increments the X and the Y are going up by. So this is a star. Look to see what increments they go up by. They might go up by 1s. They might go up by 2s. They might go up by 5s. They might go up by 10s. They might go up by 4, 11, 12. Look to see what increments it's going up. Don't assume that it's going up by 1s. All right, reading the actual graph. So you're going to interpret the meaning of the graph. If you see a flat line, the meaning of a flat line is that it's at a constant, okay? This is constant. If you see where the line is going up, okay, this is an increase. If you see where the line is going down, this is a decrease. So flat line, constant. Line going up, increase. Line going down, decrease. Pause for the calls. All right. Now I want us to look. We're going to interpret some graphs. We got a few tidbits of what to look for, okay? Now we're going to answer some questions. We're going to paste this in our notebook, okay? All right. Understanding and interpret graphs can be difficult. Understanding the relationship between X and Y is very important. All right. So the very first example, the following graph shows the distance, okay, traveled. That is along the Y, total distance, at the school. Sorry. Yeah, at the school bus, based on every morning from 6:30 to 7. So time is at minutes on the bottom. So please label the X and the Y axis. X is time, Y is motion, which is distance in this particular problem. Time and distance. I hadn't gone over that yet. I'm sorry. All right, so let's do the first one. I'm going to read it and you write what you think it is, okay? Looking at the graph. Here it says, what do the flat sections of the graph represent? Write the word that you think that is here. I'm going to pause for the calls. All right, any guesses? What do these flat parts of the line here mean? What do you think that means? This is a bus. What do you think is happening? Let's go through. What is happening from here to here? What is the bus doing? Okay, it's increasing, right? That means the bus is traveling. It's not going very fast because it's not very steep, but the bus is traveling. You know, buses don't really go that fast. And what happens here with the bus? The bus stops, okay? It's constantly at this distance. That means it's not going anywhere. So at these flat sections, the bus is stopping. Okay? Good morning or afternoon. All right. Let's think about number 2. It says, what do the steep sections mean? What do these steep sections mean? Okay, he's increasing. The bus is increasing in speed. The bus is moving, obviously, and it's increasing in speed. This is the and symbol. Increasing in speed. Okay. Number 3. Let's look at the increasing moments. I'm going to darken this. This is where it's increasing. This is where it's increasing in speed. This is where it's increasing. This is where it's increasing. These are the different places where it's increasing in speed. See if you can write or predict the speed, whether it's 17 miles per hour, 20 miles per hour, 34 miles per hour, or it's going really fast. Well, for a bus, it's going fast at 50 miles per hour. See if you can put the speeds here. And maybe there might be one that's going the same speed. Okay, see if you can make the prediction of the speeds in the table. I'm going to pause for the calls. It's going to be going the fastest. So which one of these has the steepest slope? Right here. This one is going the fastest. So this one will give the fastest speed of 50. Which one is going the slowest where it's not as steep? It has a little bit of incline, but it's not as steep. This one or this one? Are you talking about this one? No, I don't know what you're saying. Is it this one right here? No. This one? This one? Yeah. This one's going a little bit slower because it's not as steep. And probably maybe this one. That one's a little less steep than the other. That was a good guess though. So I would say this one's 17 because it's the least steepness. And so we now have 20. We got this one. We got this one. We got 20 and 34. Which one would be 20, you think?
Go up. Up.
This one?
One more.
This one, you think?
Down. Down.
This is the one that's next to it. This one,
20.
I can see how that's 20. I'll roll with you on that.
And the next one up is 30.
And the next one up is a little faster, 34. I can roll with that. This one is kind of almost close to this one. They look almost the same. So I would say this one's 50 also. And this is just estimating. All right, look at the second one. See if you can match the graph with the different scenarios. Oh, we're not doing that one. You can mark this one out. Sorry. All right, here we go. Let's look at it. All right, first thing, let's read the X and the Y. This is time. This is distance from the house, okay? And all of these are time and distance from the house. Mary leaves her house. All of these are leaving the house and walks to the store and returns with groceries, okay? So which one of these is the best fit one? This one looks like it's leaving, but then it's going back. Then it's going. All right, here we go. So this is not a good answer because this is going to the store, but then going back, then a little turn around and going back again, then turn around and going back again, then turn around and going back again, and turn around and going back again. This is not a good one for this scenario. This one is going at a fast rate, then slowing the pace down, then going back at faster pace, and then slowing the pace down and getting back. Okay? This one looks as though it's going at a steady pace, then it's stopping for a while, and then it's heading back. 3 looks like the best answer for this situation. Adjust your answer if you did not get A here, and see if you can get B, C. Oh, good folks. The second one says Roger walks around the block. Okay, so he walks around the block. So a steady pace. Then it goes a little faster, goes down, then goes back. I can see this possibly as being he's changing his pace. He gets where he's going, then he turns around and goes back. Maybe, possibly, this is a good answer. When you look at this one, start, stop, or turn around, go back, turn around, go back, turn around, go back. That's not the best answer there. So between these two, this one is the best answer. The last one, Sylvia runs the track and takes a few laps. When you do a laps, you're going basically in circles. So you're going, this is basically going in circles because they're stopping, then a turn around and going back, stopping, turn around, go back, turn around, go back, turn around, go back, and then finally just go to their destination, jogs home. So this is the better answer here. Okay, that one is the better answer. All right, I want you to paste this in your notebook. This is going to be page 9, continue. So if one person from each table pick up the supply bag. you need to take out a pair of scissors. You will need a pair of scissors for the next assignment that we're doing. And of course, you need the glue. Hurry, hurry. All right, this is 2 sheets. You should have 2 sheets. They're both different. They look very similar, but they're different. I think you just been making that up.
No, but Alice, didn't you take my pencil?
No,
Yes, you did.
I borrowed it.
You borrowed it?
All right, we need to make sure we glue that page down. Page 9 continues. The sheet that I'm passing out, you should have 2 of them. They look very similar, but they are different.
Are you sure about that? They look the same.
Is this page 10?
It's page 9.
Page 9.
Bro, I ain't got no space on there.
What have you been doing? Okay?
He like people. He like people.
They look very similar, but they are both different.
From Colombia? You from Colombia? Colombia?
Oh, don't worry about that side. You don't need that. Just move it down like that.
Mr. Ed,
Change my name. What's up, baby?
can we staple us together?
No, because we gonna it's cut and paste, so pay attention. All right, let me finish recording. No, leave it alone. Thank you, Miss Farrell. All right, let's look at this first graph here. This is saying Tom ran from his home to the bus. Look for that one. You need your scissors. We're going to cut the bottom part of the graph off right here.
I will cut it off.
We're cutting this off.
Which one? Because they look the same.
The one that's talking about the bus stop. Tom ran from his home to the bus stop.
Yeah, we just cut right here.
Yes, cut that off right there, babe. Okay, I'm going to pause for the calls. Wait for y'all to finish that part. One more time. I want you, with the people that's at your table, read the scenario and choose the correct graph or the graph that best fits that scenario and put it right up under the scenario in the box. All right, I need you to do that now. All right. The last one looks like this. Very good. Yeah, we are. All right, so guys, I need you to paste this in your notebook. Paste this sheet in your notebook on page 10. This goes in your notebook on page 10. Hold on to the other one. You're going to turn the second one in as a grade, but we're going to do that tomorrow. Clean up. Put your supply bag back. Make sure that you paste this on page 10 before you put your supply bag back. And save the other graph for tomorrow. Save the other graph for tomorrow.